All right, so law of sines with word problems. Again, these are written by mathematicians in Mathland, so they're okay. Not as bad as some. These are decent. So here they ask, find the altitude of the aircraft in the problem introduced at the beginning of the section. Okay. So if you look back in the book, that's there. All right, so we know that it's 15 degrees that this satellite pinged the plane, this satellite dish pinged it at 35 degrees, and we know the two are 20 miles apart. This is enough to figure out the height or the altitude, but I'm gonna label that H. That is the thing we're looking for. Now, in order to actually solve for H, which remember heights, altitudes are always hitting at a 90-degree angle, I need one of the other two sides of that small triangle, or that left triangle, I should say. So that 20 is the whole entire side, so I can't use that as one of my sides. I could figure out A, or I could look at the right triangle and figure out the angle, the side over there. All right, but I do have that 20 miles. So to use that 20 miles, I need the angle across from it. All right, so if they called that one A, that makes this alpha. I'll go ahead and call this one beta, which makes that B, and then we'll call this C, and this one up here is gamma. I've got two of the three, so I can find the third angle. So gamma is 180 minus 15 minus 35. So gamma is 130. So 130 goes with 20 miles. But remember law of sine, so it's the sine of 130 over 20 miles is, now if I want A, I need to use that angle opposite it. So sine of 35 over side A. Cross multiply, divide. So we will divide by the 130. So we will have the 20 times the sine of 35 divided by the sine of 130. Trig functions of angles give us proportions, which do not have units. So we have 20 miles. So this result will be in miles. All right, so let's see what those numbers give us. 20 times the sine of 35 divided by the sine of 130. So our A is 14.975, blah, blah, blah. All right, they wanted the H, and now that I know what A is, I'm going to use, I have A now, I want H, and in the right triangle in pink, I know the 15 degrees, so that's the side opposite it and the hypotenuse, so we are going to use the sine of 15 degrees is H over A. So we're just going to take that A we have in the calculator times the sine of 15. And this tells us that the height is 3.875, blah, 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 tenth of a mile. So H is 3.9 miles. So The airplane is almost 4 miles in the air. But the big thing there is being able to understand the drawing and what all it entailed. Like at the beginning of the chapter, this was a pretty hefty paragraph of text. All right, let's take a look at our last example for 5.1. We're finding the length of a ski lift. Sure. All right. So a surveyor standing down here at the bottom measures. D is down here. So here, let me make the letters a little bigger. This is D. This is Q. This is P. This is R. So DPQ is 25 degrees. Use a little highlighting here. Then he walks back 100 feet, which our drawing and what the words say do not match. Yay, textbooks. So we are going to go with the words over the drawing. So this is going to be 1. Ah, great. I need a new battery for my pen. 100 feet. Okay. And we know that angle there is 15 degrees. And they want to know PQ. The length of that side there. So normally I would have assumed they'd want the height of the mountain, but no. Okay, cool. So we know that angle's 25. So we can calculate this other angle here. That's 180 minus 25, which would be 155. And then 155 and 15 is 170. So the angle way up here is 10 degrees. And I found that third one because the side we know is 100 feet. So we need the angle across from it to use the law of sines. So we've got the sine of 10 degrees over 100 feet. And then I want to know PQ. So I'm going to call that B. And over here, that makes 15 beta. The sine of 15 degrees over B. Now this is probably going to be a silly answer, but I don't know because I don't really know how long ski lifts are to know if this answer is going to be silly or not. 100 sine of 15, close parentheses, divided by sine of 10, close parentheses, maybe. 149.047 feet. Which, yeah, they didn't give us rounding directions, but so a little over 149 feet. Maybe it's a bunny slope. Maybe it's a really small slope. That's probably why the diagram said 1,000. They probably crunched the numbers, realized 149 feet seemed a little silly, so they changed it to 1,000, but forgot to change the problem. Oh well. Still, we figured out the length. So that concludes 5.1 law of sines. Now we're going to get back to that weird side angle side situation where we have no corresponding pairs. And what do we do with that?